So in this video, we will look at the mathematical definition of an NFA. We will also compare the mathematical definition of a DFA with an NFA. So we'll do a recap of the mathematical definition of a DFA, and we will also do we'll understand how the mathematical definition of an NFA is different from a DFA. So this is the mathematical definition of a DFA, which we have already seen, right? So the mathematical definition of a DFA is expressed as M equal to, it is expressed as a 5 tuple value. So the first tuple is Q, that stands for set of states. Then we have the alphabet set, okay, which is represented by sigma, and then we have the transition function, which is represented by the symbol delta. Then we have Q0. Q0 stands for the starting state, and F stands for the set of final states. Okay. Now in the case of a DFA, the definition of delta, that the transition function is defined like this. So the transition function is going to be a function from the Cartesian product of Q and sigma to Q itself. Okay, so what we are trying to say here is that it is a mapping from the Cartesian product of Q and epsilon to Q itself, where Q is the set of alphabets, Q is the set of states, sigma is the set of alphabets. So to make it more clear, let's look at an example. Suppose your DFA has got 3 states, that is Q0, Q1, and Q2. Okay, so when I say and suppose the alphabet set is, so let me represent Q as this set, Q0, Q1, and Q2, and so Q is the set of states which are Q0, Q1, and Q2, and then let me say my sigma is going to be 0 and 1. So that's a binary strings. Now what about Q cross sigma? Q cross sigma is going to be the Cartesian product of Q and sigma. So I can represent Q cross sigma as Q cross sigma. So I have to take the Cartesian product of Q and sigma. So that will be Q. I can write it as an ordered pair, Q0, 0. Then I have Q0, 1. Similarly, I have Q1, 0. And then I have Q1, 1. Also, I have Q2, 0. Again, I have Q2, 1. So this is the Cartesian product of Q and sigma. Okay. Now, as per the definition of transition function of a DFA, it's a mapping from Q cross epsilon, the set Q cross epsilon, to the set Q. Okay. So we know what is Q. Q is going to be so Q is going to be Q0, Q1, Q2. So this function is a mapping from Q cross sigma to Q itself. So it means that you can have, since it's a function, you can have only one image of when you look at Q cross epsilon and Q, if you take one element at Q cross epsilon and map it to Q, okay, so the mapping should contain only one image. That means Q0. If you look at Q0, 0, suppose it is mapped to Q0, right? Now it should not have another mapping. Similarly, suppose if Q0, 1 is mapped to Q1, okay, so there should not be any other mapping for that particular item in Q cross sigma, right? So all these entries that you see in Q cross epsilon should only have one mapping to the set Q. So that's the meaning of a function, right? So you can also imagine this. You can draw the diagrams. Okay, you can draw these the diagram for the set for Q cross sigma as well as Q, and then you can draw the mapping. Okay. So if you look at this mapping, so for one of the entries in this Q cross epsilon, you should have only one image. You should have only one image in Q. Okay. So that's a condition here. Okay. So now let's understand the mathematical definition of an NFA. So the mathematical definition of an NFA, when you define the mathematical definition of an NFA, so this is going to be remaining the same. Okay, there is no change in this. Okay, the only change that you have is in the definition of your transition function, right? So the only change is reflected in the case of the transition function. The difference is that in the definition of transition function, the mapping is from Q cross sigma and Q cross sigma to the power set of Q. So instead of Q here, let me erase Q. So that's a key difference here. Okay. So instead of Q, the mapping is defined to the power set of Q. So let me express the power set of Q as P of Q. Okay. So I will also explain what you mean by the power set of Q. Okay. So the power set of Q is actually the set of all the subsets of Q. Okay. So you know what is the set here? What is the set of all the states that's represented as Q? Okay. So we know what is Q. It contains Q0, Q1, and Q2. Now we are interested in the power set of Q. So the power set of Q is going to be the set of all the subsets of Q. So let me write down the power set of Q now. So let me modify this itself and write the power set of Q. So the power set of Q, let me erase this. So we are going to modify this set as the power set of Q. Okay. So let me erase these things and I will write the definition of the power set of Q. So as I told earlier, the power set of Q is going to be the set of all the subsets of Q. So which are all the subsets of Q? So we know Q contains all these values. That is Q0, Q1, and Q2. This is the set Q. So the set. So we want to find all the subsets of Q, all the subsets. And that's what is the power set, all the subsets of Q. So to start with, we know that null set is a subset of every set. So null set will be one entry in this. And then we will write single element sets. That is, we have Q0, Q1. Since all of these are subsets, I am writing everything in brackets. Okay. Now let me write the two element subsets. So it is possible to have Q0, Q1. That's one possibility. Then you can have Q0, Q2. You can also have, we have written Q0, Q1 and Q0, Q2. Okay, we can have Q1, Q2. That's also possible. Q1, Q2. Okay, so I think we have written Q0, Q1, Q0, Q2, and Q1, Q2. Okay, these are all the possibilities for writing the two-member subsets. Now we have one more. That is the entire set itself. That is Q0, Q1, and Q2. So the set itself is a subset of that, right? Now, what we expect here is that if Q contains n elements, okay, if Q contains n elements, the power set of Q. If you look at the power set of Q, then it will contain 2 raised to n elements. Let's quickly verify this. So in Q we have 3 elements, Q0, Q1, and Q2. So we expect that we should have 2 raised to 3 elements in P of Q, power set of Q. So we should have 8 elements, right? So this is going to be 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, okay. So our power set is complete here. So we have written the power set of Q. Now in the definition of the delta for NFA, so for NFA, we are going to define this as a mapping from Q cross sigma to P of Q. It's going to be the power set of Q. Okay, it's not Q, it's going to be defined on the power set of Q. Now, as per the definition of the transition function, we should define a mapping for every item in Q cross epsilon. For every item in Q cross epsilon, it has to be mapped to one of the items in the power set of Q. Okay, so let's look at the previous example that we were discussing. So you may be you can recollect that this one is going to be the NFA to accept binary strings ending in 0, 1. So this NFA was designed in our previous video. So I'm taking the same example. I'm taking the very same example, and then I'm going to show the mapping from Q cross sigma. Okay, Q cross sigma to P of Q. So the power set of Q. So if you look at Q0, let me take my pointer. So if you look at Q0, from Q0, so Q0 on 0, what we should do? Okay, Q0 on 0, you have two possibilities. You can either go to Q0 itself or go to Q1. So when you get a simple 0 at Q0, then you have two possibilities. So that's why we are going to map this Q0, 0 to this particular value, that is Q0, Q1, right? So we can either go to Q0 or go to Q1. Okay, so I will be mapping this. Okay, so let me take. Okay, so Q0, 0 is going to be mapped to Q0, Q1, right? Because yeah, I can either stay at Q0 itself or I can go to Q1. Okay, that's the transition that's the mapping of Q0, 0. So let's look at what's going to happen for Q0, 1. Okay, for Q0, 1, Q0, 1, the transition is defined on Q0 itself. There is no other definition, right? So Q0, 1 is going to be Q0, 1 is going to be Q0 itself. So here we have Q0. Okay, so we have Q0 here. So we are going to map Q0, 1 to Q0 itself. What about Q1, 0? Q1, 0. Okay, so Q1, 0. If you look at the transition diagram, Q1, 0 is not at all defined, right? So you don't know where to go, or it is not defined. That means this is a very key understanding. If you look at Q1, 0, there is no path defined, then that should be mapped to the null set, because since there is no map, the transition for 0 is not available there, right? So it should be, so in our mathematical definition, we are going to map such items to our null set here. So I'm going to map Q1, 0. If you look at the DFA, there is no mapping, there is no transition on Q1 from Q1 on 0. So I'm going to map it to the null set. And what about Q1, 1? Okay, you can see that Q1, 1, if you look at here, Q1, 1, it goes to Q2. Okay, so Q1 upon 1 is defined transition is going to Q2. So I can say Q1, 1. So Q1, 1 has to be mapped to Q2. Q2 is here, right? So I can map Q1, 1, to Q2. Okay, so far I have mapped 4 items. I also have to map the left two more items. So what about Q2 comma 0? Okay, and Q2 comma 1. It's very easy. There is no transition. There is no transition defined on from Q2 on 0 and 1. You can see that there is no transition defined from Q2 upon 0 and 1. So naturally this should go to the null set. Both these entries, that is Q2 comma 0 and Q2 comma 1, should be mapped to the null set itself. Okay, so let's do it. So Q2 comma 1 is going to be mapped to the null set, and similarly, so I'm going this way. Similarly, this is also mapped to null set. Okay, so you can see that from Q cross epsilon, you have mapped every item to a single item in the power set of Q. Okay, so every item in Q cross sigma is mapped to one of the items in P of Q, power set of Q. Okay, so that is guaranteed, and now the definition is holding here. So this is the elegance of mathematics. So whatever we have told in the earlier video is just expressed in these two statements. So if you give these two statements, so the entire idea of NFA is clarified. So for a mathematician, he requires only these two statements to understand what is an NFA. So the funny part is that whatever that we have discussed in the earlier video, which was having a duration of 20+ minutes, all those things are expressed in these two statements. Okay, so this is going to be the demonstration of how mathematics can express ideas in a very crisp way. Okay, and again, I also want to highlight one more thing, that is P of Q, the power set of Q, the representation for power set of Q, is equivalently written as 2 raised to Q in some of the textbooks. So some of the textbooks follow this notation. So instead of saying power set of Q, they say it as 2 raised to Q. So this also refers to the power set of Q. Okay, so if you find such a notation saying 2 raised to Q, then it actually refers to the power set of Q. Now this actually refers to the idea that if the set Q contains n elements, then the power set of Q contains 2 raised to n elements. We have witnessed that in our example also. So when we had 3 elements in our Q, then we had 2 raised to 3 elements in our power set of Q. So in the next video, we are going to start constructing NFAs for given problems. So with this background, we'll be able to design NFAs for the given problems. So the design of NFA is considered to be much easier compared to the design of DFA, just because of the fact that we don't have to provide transitions for every symbol, because we can only represent the essential informations and then proceed further.